Today we're going to be looking at reaction time and thinking distance. The learning objectives are to explain how reaction time can be measured, calculate thinking distance, speed or reaction time using the relationship between them, and explain what reaction time is and how it affects measurements. We're going to start by looking at what reaction time is and how it can affect the results of measurements. In the Olympics, for example, you wouldn't expect someone to use a stopwatch to try and time a race because humans simply can't react quickly enough to record it accurately or precisely. This is because of reaction time, and for a human it's normally about 0.2 of a second. One way you can record your own reaction time is by having someone else hold a 30cm ruler above your hand and then drop it with no warning and see how quickly you can grasp the ruler. The distance the ruler travels indicates your reaction time. Light gates are a very good way of eliminating reaction time as a variable in experiments, particularly if you have something that's moving very fast, such as a falling object. You are expected to remember a typical value for reaction time. Something of about 0.2 of a second is ideal, and we'll use this for equations later. This image is taken from the highway code, and it shows on the left hand side the grey arrows representing the thinking distance for various different speeds. But what is thinking distance? Thinking distance is the distance the car will travel while the driver is reacting to the hazard. So the distance it travels from seeing the hazard to applying the brakes. Looking at the image again, you'll see that the thinking distance is proportional to the speed of the car. This makes sense as the reaction time is going to remain constant, and the equation speed equals distance over time means that as speed doubles, distance doubles. You're going to see some pictures of things that can affect reaction time. Try to guess what they're representing before the answers come up. Alcohol is a depressant and can slow down our reaction time. Drugs can either speed up or slow down our reaction time depending on the type. Tiredness can make us slower to react to hazards. As we get older, our reactions tend to slow down. Distractions from other people in the car can also affect our reaction time. Eating and drinking whilst driving can make us slower to react. Trying to use a radio or sat-nav can provide another form of distraction whilst driving. Now, to calculate the thinking distance, the first thing we need to do is convert the speed from kilometers per hour into meters per second. There are 50,000 meters in 50 kilometers, so we have 50,000, and then we need to divide that by the number of seconds in an hour, 3,600, which is 60 times 60. So we would end up with a speed of 13.9 meters per second. And then we use the simple speed is distance over time equation, rearranged to find thinking distance, and we end up with 2.78 meters. Now it's your turn to have a go. Follow the same procedure by changing it into meters per second first, by timesing by 1,000, then dividing by 3,600, and then once you've got the speed, times it by 0.2 of a second for the normal human reaction time. Remember to pause the video after you've had each question to give yourself time to come up with an answer. For this first question, you're trying to find the thinking distance for a car travelling at 130 kilometers per hour. So don't forget to change it into meters per second first and then find the thinking distance. To convert 130 kilometers per hour into meters per second, you need to first of all times it by 1,000 to go from kilometers to meters, and then divide by 3,600 to go from hours to seconds. That would give you 36.1 meters per second. Now to find a thinking distance, you just times reaction time of 0.2 seconds by the speed of 36.1 meters per second to give a thinking distance of 7.22 meters. The next speed limit is 80 kilometers per hour, so remember, convert it into meters per second first and then calculate the thinking distance. To convert 80 kilometers per hour into meters per second, you would times by 1,000 to get it from kilometers to meters, and then divide by 3,600 to go from hours to seconds. If we have speed in meters per second, we can times it by 0.2, the normal reaction time, to find a distance of 4.44 for the thinking distance. This time the speed limit is 100 kilometers per hour, so once again change it into meters per second first and then find the thinking distance. And again, to find the speed in meters per second, we times by 1,000 to go from kilometers to meters and then divide by 3,600. Once you have the speed, you can times that by the normal human reaction of 0.2 and you'll get a thinking distance of 5.56 meters. That brings us to the end of today's lesson, so thank you and I hope you found it useful.